Hello, it's Mr. Thompson here again, and I'm here today to talk you through some Grade B at GCSE or Level 8 at Key Stage 3 material. Today we will be talking through an example of using trigonometry to find missing sides, and that's going to be exclusively with the cosine ratio. Okay, so let's get started. The first thing that you are going to need to be aware of is that you will need a calculator for this work, and on your calculator, if you look up towards the top, there will either be an R or a D. You need the D for this work. The D stands for degrees and the R stands for radians. That's not something we know how to use just yet, so you have to make sure your calculator is set to D for degrees. If not, you will need to change your settings. So our first question here, we are being asked to find the length x from this triangle here. The information we've been given is that this angle here is 60 degrees. This is obviously a right angle. This length here is 6 centimeters, and we need to find this length here. So the first thing that we need to do is to identify all of the sides. So remember our previous work on this, we have done the first thing is to identify the sides. So we have this angle here is 60 degrees. Remember, this side opposite that angle is in fact our opposite, just over opposite. The side that is opposite our right angle is always the longest side of a right angle triangle, and that is called our hypotenuse. And then this length here, that is where the angle sits on this 60 degrees. Where that sits, that side is called the adjacent. Okay, so now we're going to look at this this little sentence here. So katoa. We are looking to find this adjacent side, and we have been given the hypotenuse. So which of these ratios includes the adjacent and the hypotenuse? Well, we can see that that is the C-A-H. So we're going to write out over here our cosine ratio, which is cos of the unknown angle theta is equal to the A, which is our adjacent, divided by H, which is our hypotenuse. Okay, so that's the ratio. We're now going to use that ratio to solve this problem. So the first thing we're going to do is we're going to write this out again, but this time instead of the theta, the adjacent and the hypotenuse, we are going to substitute in what we know from this diagram. So we're going to write it out again. Cos, instead of theta, we know that the angle we've been given is 60 degrees. So we're just going to write cos of 60. And that is equal to our adjacent, which in this example is x centimeters, divided by our hypotenuse, which in this example is 6 centimeters. Okay, now what we need to do is we want to find, as with any equation, we want x on its own on one side of the equation. As you can see, we have cos 60 equals x divided by 6. So on this side, if we have x divided by 6 and we just want x on its own, we need to get rid of this divided by 6. So we're going to do the opposite of divided by 6. Let's put this in red. Is times by 6. Now remember, whatever we do to one side of the equation, we must also do to the other side of the equation. So 6, on this side we're left with 6 times cos 60, and I would always put this in brackets. Especially with some calculators, I would recommend that we always put that in brackets, the cos 60. X divided by 6 times by 6, we are just left with x on this side. So now, if I was to put that into my calculator, 6 times open brackets cos 60 close brackets is equal to, that comes out as 3 centimeters equals x. So we have just used the cosine rule to find x, which is 3 centimeters. Sorry, the cosine ratio. X equals 3 centimeters. So this length here, we can now say equals 3 centimeters. Okay, let's try another slightly more difficult example. Okay, so our slightly more difficult example is just like this question here, and we want to find x whatever the x is here for x centimeters. As before, the first thing we need to do is identify which is our hypotenuse, which is our opposite, and which is our adjacent. So remember, the angle opposite this angle here, the angle we are given, it won't always be this angle by the way, it could be this one up here. Anyway, the angle opposite this one, sorry, the side opposite this one is called our opposite. The side opposite our right angle, the longest side, is always called the hypotenuse, and the remaining side that the angle sits on is called the adjacent. Okay, so once again we can see that we want one of the three ratios from the SOHCAHTOA, which I've got rid of here, that includes the adjacent and the hypotenuse. That is our cosine. Again, we're going to write it out as we did before, but this time with what we know in. So we have cosine of theta, which in this example is 50 degrees, and that is equal to whatever the adjacent is, which in this question here is 7 centimeters, and we are dividing that by our hypotenuse, which is x centimeters. Okay, now what makes this question slightly more difficult is that in the previous example the x was on top of the division here. It was the numerator in this fraction. This time it's the denominator, it's the bottom number. So to get rid of this x on the bottom, we're going to need to do an extra step. The first thing we're going to need to do is get rid of this horrible division where x is on the bottom. So 7 divided by x is on this side. So what we want to do is undo this horrible division. We're going to times both sides by x. Times this side by x, and times this side by x to get rid of this divided by x. That gives us on this side x times cos 50, remember always put this in brackets, equals 7. Okay, now x times cos 50 equals 7. What we want to do now is get x, now we've got it out of this horrible fraction, we want to get x on its own on one side of the equation. So x here has been times by cos 50, so to undo that I'm simply going to divide both sides by cos 50. So whatever I do to one side, of course, I have to do to the other. Okay, so x times cos 50 divided by cos 50 just leaves me with x. And on the right hand side of the equation I have 7 divided by cos 50. When I put 7 divided by cos 50, always in brackets remember, into my calculator, to one decimal place I get 10.9 centimeters, and that there is our final answer. So we have found out that x, this length here, is 10.9 centimeters. Our hypotenuse is 10.9 centimeters. What makes this question more difficult, just to clarify, is that extra step because x is on the bottom of this division over here. Okay, I really hope that's helped. I will do, there will be a separate video for both the tangent and the sine ratios, using those to find missing lengths, and I will also do some videos on using those ratios to find missing angles. Hopefully that's been of use. Until next time, I'll see you later. Bye bye.